Hello, everyone. In today's webinar, we are going to have slightly different angle. We are going to discuss HC3 platform and how backups can be done on such platform as well. And today with me, I have Alan Conboy from Scale Computing. Alan, if you could introduce yourself, say hello to everyone.
Hi, everybody, and thanks for taking the time to join us. This is an event I've been looking forward to spend some time with the Storeware team. These guys are absolutely outstanding, and I thoroughly enjoy working with them.
Thank you. We also enjoy. So, brief introduction to everyone.
Okay, so my name is Alan Conboy. I'm the Office of the CTO here with Scale Computing. I'm about a 30 or so year veteran of the industry across the board. I was actually one of the first movers in the hyper-convergent space. If we go back a decade and change, also one of the first 30 people ever certified by SNIA.
Okay, now let's maybe give somebody a short insight into my role. My name is Marcin Kubacki. I'm Chief Software Architect at Storeware. We are, on the other hand, in the well, backup in general area. However, I have touched both virtualization, infrastructure, IT infrastructure in general, and programming at the same time. So I roughly let's say connect or join these two words easily. Now, Alan, brief
Yeah.
introduction of the brief overview of the HC3 to everyone.
Okay. So the Scale Computing platform called HC3 is something
But
that we've introduced roughly a decade and change ago to the world writ large. It is the platform for which the term hyper-converged was actually coined back in 2011 to describe. Okay. Now, Scale Computing, we're a global company. You'll find us everywhere from the United States to the Royal Court of Bahrain to the City of London to Japan to Australia and New Zealand to, oh, you name it, we're there. Okay. But what, at the end of the day, Scale Computing is really all about, well, it's an all-inclusive clustered architecture that is built very specifically to make virtualization, containerization infrastructure easy to use so that anybody from a store manager to a barista to an IT person can stand up infrastructure, get their workloads going with very, very little effort. And more importantly, it's self-healing, self-load balancing. It's a platform that lets you not have to think about your infrastructure and instead focus your time, effort, and energy on the things that actually move your business forward. Okay. Now, there was a lot of reinventing the wheel that went into building HC3. Now, people ask me, why did we spend the time reinventing the wheel? Folks, they've used VMware. They're familiar with it, kind of a demon you know sort of thing. Well, let's take a look at the lay of the land, the way the world was prior to Scale introducing HC3 to the world. Okay. If you stop and think about how legacy virtualization works, servers plus switches plus SAN plus hypervisor and so on and so forth, it was complex. It was kind of horrifically complex. You'd start with a shared storage platform, SAN or NAS, doesn't really matter which. Carve your RAID sets, your protection space, your snapshot space, all kinds of gotchas there, limitations and speed problems. Now, when you did that, either a file system or a pseudo file system got layered right across the top of those RAID sets. You know, with NetApp, it's Waffle. With Isilon, it's OneFS. With the left hand or any of those, it's a global DB style approach. Okay, it's where all the benefit of SAN came from, but at the end of the day, it's also where all the resource consumption of SAN lived as well. Now, on top of that guy, you'd then have to bring in redundant switching for multipath IO and so on and so forth. You'd have to bring in your management server, your physical servers, layer hypervisors onto them, map redundant pathing across the board. Okay. And then you'd have to stand up your storage targets. Okay. Your iSCSI LUNs for simplicity's sake. Nobody ever asked themselves, what actually is an iSCSI LUN, though? iSCSI or fiber channel, doesn't matter. The short answer, Marcin, is, well, it's an object file. It's a sparse file. It's an empty file sitting on a file system, sitting on a RAID set. Then that object file got mapped across a network fabric on top of the overhead of protocols, on top of the overhead of IP, to create a legacy construct that we all knew as a data store, right? But ask yourself, what's a data store? It's an empty file. It's an object file. It's a sparse file mapped across a network fabric, sitting on an object file, sitting on a file system, sitting on a RAID set. And then what was the first thing that happened to create that data store once the object file was in place? Another file system. VMFS if you're talking VMware, NTFS if you're talking Hyper-V, EXT2, EXT3, EXT4, ReasorFS if you're having a really bad day in the KVM and Linux space. But yet another RAID set, or yet another file system, sitting on an object file, sitting on a mapped across a network fabric, sitting on an object file, sitting on a file system, sitting on a RAID set. And then you'd actually create your virtual hard drives. This is how we all lived from an infrastructure perspective for what, 2 decades. You know,
And that
these guys,
includes also all of the guest file systems inside all of these VMs.
oh, it just gets worse. Because I mean, right here at this level, this is your VMDK. This is your VHD, your VHDX, your QTOW2. And what is it? It's an empty file. It's an object file sitting on a file system, so on and so forth, all the way through the chain. Then you finally get to where you could spin up your workloads, install the VMs, and what's the first thing that happens? I'll give you a hint. The initials are NTFS. Yet another file system. You're starting to see how incredibly inefficient everything legacy virtualization wise was. It was horrific. I mean, to do something as trivial as change a period to a comma in a Word doc in this workload, in this virtual machine, you were dealing with no fewer than 7 hops each way, coordinated through what, 3, 4 different kernels? You had to deal with a file system, sitting on an object file, sitting on yet another file system, sitting on yet another object file, mapped across a network fabric on top of the overhead of protocols, to yet another object file, sitting on a file system, sitting on a RAID set. 7 hops, 14 hops to do anything. Okay. Well, what we here at Scale did was essentially with our platform, got rid of everything that didn't need to be there in the first place, put the remainder where it should have been all along, creating an infrastructure that anybody can use. Every node running a state machine so that every node is talking directly to every other node. That management server, don't need it, don't want it. The nodes talk directly to each other to do the exact same IO operation. Well, 3 hops, done. You can see the obvious implications here from an IO pathing perspective, from a management overhead perspective. There's no storage protocols, don't need them. The nodes just talk directly to each other, making life
if
simpler.
they have to read data which is slightly more commonly used, I would say that VM resides on one host. Is there some sort of caching layer?
So every block of data is actually round robin chain committed to 2 separate drives on 2 separate nodes. So first block might go here and here, next block might go here and here, next block might go here and back here. And the first responder on any read operation, because both copies are used in parallel, right? First responder gets there. So the need for legacy caching operations basically disappears. When you look at how other folks in the space do things, it makes you long for just 7 hops. Some of these virtual SAN appliance VSA or CVM based approaches, they consume 12 to 14 hops each way, plus a duplicate set of RAID penalties for every node. Okay. The obvious translation here, the net takeaway, is Scale's approach, while perfectly fine for the large data center, the SMB and mid-market, the distributed enterprise, our approach consumes less than 1/10 of a single core and slightly less than 4 gig of RAM per node. Everybody else in the space is consuming 12 to 24 cores or more, 96 to 300 gig of RAM across a 3-node cluster, just to be able to boot themselves up. Well, with HC3, it's usable by anybody, but more importantly, the resources that you buy actually get used for workloads, not for overhead, if that makes sense.
Oh, that's
Okay.
perfectly clear.
So a moment ago, I talked about how our stack is incredibly tight. It only consumes very, very lightweight on resources with a full-featured top-to-bottom HCI stack, right? Well, what that means is that Scale Computing's platform can actually fit on devices as small as the Intel Compute Card, the Intel Element and NUC, the AG150. Now, what that means is this brave new world we're all going into called the distributed edge. Everybody went running to the cloud and then discovered not everything belongs there and started pulling about half of it back. This allows you to run an entire top to bottom HCI stack in places where IT doesn't exist anymore. Places like gas stations and grocery stores, places like shipping companies, on the ships, out in the ocean, the oil derricks. This allows you to have a top to bottom fully featured data center grade HCI stack that self-heals and self-load balances that you just don't have to think about in places that, well, let's face it, you don't have VCPs and CCNEs and SNIA certified storage engineers. You have ship's crew, you have store managers, you have baristas. Well, that efficiency that's inherent in the Scale Computing platform allows these edge implementations to exist. Okay. Now, one of the other things I'm only going to touch on briefly, because we're going to do a real big announcement next week, is fleet management. It's part of it as well. So that one guy in one location with one browser can administer thousands of locations with one click. I'll show it to you briefly, give you a little sneak peek here in just a second. But I guess the high level for the audience, we're trying to, just who is Scale Computing? It's not so much about what you do need. You get all the table stakes and some things you didn't even think of. It's more about what you don't need. There's none of the VMware licensing and VTech stuff. You don't have to deal with SAN, storage protocols. There's no management servers. You don't have to have dedicated virtualization administrators. Put those people onto DevOps and things that they actually enjoy. That cluster will keep things going without you having to invest that kind of resource. You can mix and match, no overbuying on the front end. And let's face it, you don't need to be a PhD. You don't need a bunch of guys from a bunch of different disciplines just to make your fundamental infrastructure work. Here, I'll tell you what, let me show you what I mean here. Right here, here's that management portal, and at a glance, I can see the state of multiple nodes, multiple clusters across the board globally. And if I want to see what's going on with one of them, here, let's see. We'll jump into this guy, 3750. He's showing that, hey, he's got different workloads up and running. I can see at a glance which VMs are running, which ones are shut down, what load levels work like, whether or not he needs a firmware update. Heck, I can apply it non-interruptively from a single click right here. Okay. I can literally control my entire fleet. Now I can drill down to the individual cluster level just by clicking on the name. And at a glance, I can see my entire infrastructure, do things like live migrations and all of that good stuff. All the things you expect, again, with just a click. This is what you call novice friendly. and expert capable. So I don't want to spend this whole conversation just talking about scale. I'll be more than happy to answer anybody's questions offline from here. But what this is really all about is something that you mentioned, Marcy, the ability to simplify, radically simplify backups, data protection, etc., that Storeware brings to this partnership. So rather than me sitting here and pontificating, how about you talk to us and show us what Storeware and your team has done to integrate with the scale computing platform?
Okay, so let me have also a brief introduction of the overview of our solution. So major features. The solution itself actually focuses around agentless protection. So we also want to have a modern approach, and especially when we talk about modern infrastructure like this. So without any need to install any agents, if you have scale cluster, you can enable VM level data protection for such cluster. And we also support several other features that includes also the Office 365 support multiple different sources. But from the scale perspective, especially important it is that we have synthetic backup providers support, which allows you actually for quicker recovery of your backups without the need to merge the chain of the data, and especially that you don't always have, especially on the edge computing, sophisticated hardware. Then option to integrate with any other, well, most of the key players on the market from the backup perspective, like the enterprise grade backup providers, IBM, Dell, etc. And RESTful APIs if you really want to have slightly more complex scenarios covered. Now, this landscape actually in many cases, well, probably we're not going to discuss all of these different sources and targets, but you can see it has grown. We have started with the vProtect. Now it's a single solution, Storeware Backup and Recovery, which, as you can see, covers basically all of the areas on the market. And on the right side of this picture, this is the place where you are able to store backups of your HC3 virtual machines. So this is completely transparent regardless of what kind of infrastructure do you have. Now, scales, and so because we are also prepared for scale out, in this case we have actually two components. One is the server. This is the place where you actually click and play, and one is the node. This is the data mover, which talks to the different, well, clusters. It can be done like this. Environments, it doesn't matter, but nevertheless nodes are responsible for actual data movement. And we have two strategies for scale, actually. One is the native approach, which is also built in the scale itself. So we wanted to first focus on the, let's say, primary choice that you have in the scale cluster. So a snapshot is taken, and we are able to invoke the complete export of the VM. So it's a full backup only to our SMB share on the node. It is our export storage domain approach, similar what we started with the, for instance, ref environments or other platforms like legacy already, Oracle VM, for instance. It works perfectly fine. It's simple to also to understand. However, it doesn't support incremental backups. This approach is very good if you would like to use the native approach. However, Scale also provides APIs necessary for incremental change block tracking way of doing backups. Now, this is a completely different story. Now, in such scenario, you have to deploy a virtual machine on the cluster. It's a proxy VM, and we are able to snapshot and attach drives directly to our proxy VM. And using these APIs, we will be able to do incremental backups and just read the necessary blocks. So full backups obviously will dump all of the contents of the drive, while incrementals will only read necessary data. Well, drawback is that you need this proxy VM, but anyway, incremental backups work definitely faster. So let's have a short demo in this case. I will share now the different tab. Okay, so here I have my scale cluster. As you can see, there are some VMs already running in there. One of them is my backup test VM. And now let's log into my Storeware Backup and Recovery. I'm logging. And as you can see, obviously, I have now significantly more compared to vProtect in version 4 sources available. Inside the dashboard, you will see that I have two nodes. One of them resides on this HC3 cluster and is responsible for doing backups using the disk attachment method. I'm using here a synthetic backup provider, synthetic file system. So the cool thing is that you actually are using any file system, sorry, not any, but initializing file system on any block device is not a big problem. XFS actually in this case is required, but also you can bundle it with the data domain, for instance, if you would like to have a very effective deduplication. And you, for some reason, you don't want to use video, which is also what we support by default. Now, in the virtual environments tab and infrastructure, this is the first place where you add your HC3 cluster. You can, as you can see, I have defined one in here. It is available on the list, and you are able to choose what kind of backup strategy you would like to use. Notice that this also can be overridden per VM level. If you, for some reason, would like to export one of your VMs in a different fashion, then you can later override this on the VM level as well. In my case, I have this already defined, and you attach actually the environment, this manager, to the node configuration. In the past, it was an individual node, but now actually you can deploy multiple nodes that are treated in the same way. So if you have 10 backup tasks actually on the same cluster, this actually could be assigned to two nodes running on the same cluster if you would like to boost your backup process. Anyway, I have quite simple cluster in this case. I have this one cluster available, so I don't have to multiply the nodes, and it detected already several virtual machines that I have in my environment. So let's invoke backup process. Incremental backup is available. We will initiate backup task. Is actually creating an export task here. Store actually means that we are able later to push data to some, let's say, S3 object storage. It doesn't really matter what actually you are using behind the scenes. Whenever I say object storage, majority of the deployments I noticed both on-prem and off-prem use S3, I would say, protocol APIs is a better word in that case. It means that if you have a S3 compatible storage, you are able also to use this solution. But if you go back here and on the in the backup destinations tab, notice that I can actually use additional object storage types. All of them are the key of them are available, and Swift, also used by the OpenStack environments, is available as well. Anyway, we really recommend S3. Is actually the one that is most versatile. And file system, if you would like to use synthetic, it basically allows you to initialize anything or what you want on the block devices that you are able to expose to your environments. Now, with the single solution, you obviously are able to cover as well the other sources, not only the HC3 cluster, but with the application backup, you're also able to go a little bit deeper into the infrastructure. And if you have some databases, some applications where you just want to centralize your scripts or native backup commands in a single pane of glass, this is the place where you can define or use pre-existing execution configurations and actually use them to run custom backups inside your cluster as well. So it is not only about the virtual environments, like I have executed backup on my VM in here. And notice that there were some backups in the past already being completed. So here are some statistics. You are also able to do backups on some system that resides in there, regardless actually if it's a VM or not. And this is especially useful if the snapshot based backups are not enough for you. In the settings, notice that you are able to specify different backup policies. Our backup policies now support also the backup copy feature. It means that whenever you define a policy in here, using rules, you're able to define that for this, some of the backups according to one set of schedules are going to be stored in one backup destination. Optionally, a copy will be transferred to the secondary backup destination. But you can add more rules which also are going to execute completely different set of these schedules and push backups to the other backup destinations if you wish to, or the same as well. So this allows you to define quite complex scenarios as far as the backup process is concerned in a relatively easy way. You don't have to install any agents on your VMs. So once you have just connected your cluster, so provided your credentials, you can run inventory synchronization, or it is also going to run periodically to refresh the state of your cluster, and suddenly you are able to just execute backups according to the policy that you have defined. So policy obviously is the step that you need also to define in the first place. Now, obviously, you can add more nodes. Notice that I have here just 2 of them. They have separate node configurations. So using the same server, you're able to manage multiple nodes, multiple data movers, and they will simultaneously execute jobs according to limits that you have actually configured. So if you don't want to stress too much the infrastructure, then you can also limit to the number of threads, and all of them will be executed by the different set of nodes. All of the tasks will be visible within a single console that is available in here. One very cool feature is that you also are able to specify recovery plans. So recovery plans, unlike regular restore, you don't have to just restore individual VMs, but you define sort of a policy. This policy can have actually multiple rules, and each rule allows you to specify, well, let's say rule 1, set of criteria, set of settings for the virtual machines of the same type. We have scaling here. So if I would like to just limit to the backup VM, like this one, for instance, I can optionally create a schedule for recovery plans so that periodically I will have VMs being restored. Then I can specify restore parameters. And for the regular restore, you would specify which particular backup you would like to restore. But because it is sort of a generic way of creating the plan for your future disaster recovery, we would like, let's say, to specify last successful, or if you would like on purpose fail the restore process for reporting purposes, you can specify last regardless of status. It is obviously going to fail if you don't have last backup successful, but you will have that at least in your report, and you will have sort of an additional test if your backups are fine or not. Now, this allows you to define batches of the restore process. So it's not only about restoring individual VM, it's also about restoring batches of such VMs, maybe between different clusters. Okay, so not to maybe make it any longer, I believe now it's a good time for Q&A session. So let me stop sharing, and let's go back to the questions tab. Will the recording be available? Yes, it is going to be available. Now, please type in your questions in the questions tab or in the chat, and we are going to try, at least try to answer all of your questions during this webinar.
Oh, absolutely, folks. Please feel free. Fire questions away. I vastly prefer this be an interactive discussion rather than just a preaching session. So if you have questions, comments, thoughts, or concerns about what you've seen so far, please feel free.
Remember that actually, if you have the box, like Scale comes to you and you have installed everything, Storeware is a piece of software. Well, it also comes as a virtual appliance, but eventually, probably you may want just to install simple CentOS and just run our installer so that it puts everything on top of this small VM. So that's usually how you would approach such scenarios. In my case, this required one of the VMs to reside in this cluster, and this is one of the things to note. What about
Okay,
citing
Wolfgang.
for Storeware
Yeah.
proxy VMs? Well, in general, we require around 4 gigs of memory for very base setup, both server and the node. If you have, let's say, the single cluster without any additional nodes, then 4 to 6 gigs of RAM plus CentOS, let's say, stream minimum or rel, if you wish to do. And the biggest thing is actually the storage space. Okay, you have to allocate some space for the staging space, but you can optionally use the same space for having the backup destination. And you also have the option to use the duplication for such case. So this obviously depends on the size of your VMs and number of simultaneous tasks if you have separate disk for just staging. So this is worth to mention. But from CPU and RAM, 2 vCPUs, 4 gigs of memory as a base installation is perfectly fine. The staging space now, notice here that I have purposely mentioned that you can join them together. So in the Storeware Backup and Recovery, it is quite common to use piece of the storage, let's say piece of the storage, and use them together with the staging space. In this case, actually, whenever we backup, we don't have to rewrite it later to our backup destination. We just move the files to appropriate locations, and it boosts the overall backup process. And because you are able to easily do duplication to inside the Storeware, you also will save significant amount of space in that matter. As a rule of thumb, if you just want to focus, let's say, on staging space, it's the number of the simultaneous backups multiplied by the number of the biggest VM. But this also so the staging space resides on the scale. Well, it resides on the node. So because the node resides inside as a VM, if you are following the disk attachment process, which probably you are going to do, deploy in such case, especially that incremental backups will work significantly faster than regular complete export of the using the SMB shares. Then yes, it is going to require additional space on the scale cluster, well, because it's going to be a local drive on this VM. But there is no restriction from our perspective to attach any external, let's say, data domain, for instance. A good option as well. So if you have the BoostFS, for instance, available, you could attach your external data domain and expose it both as the staging space and the storage for your backups. And it is quite normal setup in our scenarios. In many cases, data domain is one of the its advantages for using the duplication and performance makes it highly recommendable for many deployments. It's not obligatory, but yes, it is one of the way to go. So, and notice that it doesn't mean that your staging space resides in the scale in this case. The very basic scenario, yes, just attach an empty drive, virtual machine disk on the scale.
Sure. And one thing I might add there, you're not limited to the capacity of a single node here. When you're talking about a scale computing platform cluster, all of the drives in all of the nodes are shared together as at a block level. So as you add nodes, you're actually adding capacity, and as you're setting up that staging space, if you choose to do it on the cluster, etc., it's actually shared and duplicated across the entire cluster as a whole. Okay.
Okay, Wolfgang, I see that there is another question.
So while Wolfgang is asking a few questions, are there other questions from the audience that we can answer as well?
Any other questions?
Well, it looks like we have one coming in from Samuel.
What about
Okay.
edge?
So this is very, very interesting. While other companies have been arguing and discussing what the edge is, Scale has been actively selling into it for the last, 4 or 5 years. As a matter of fact, they're in Europe, the second largest grocery store chain in the world, Ahold Delhaize, standardized on scale computing 3 years ago, putting nodes, HC3 nodes, some as small as our HE150 lines, at every single location, at every store, and then managing all of that through that platform that I mentioned a few moments ago. Now, it is the exact same stack at the edge sites on these tiny nodes, these HE150 nodes, as you find on the 1U and 2U and 3 larger implementations. And the Storeware platform works absolutely perfectly there as well. Okay. The deployment strategies, well, we've got some really cool stuff coming, but let me just say this. Imagine being able to send the devices directly from the manufacturing factory straight to where they're going to live, whether it's at the gas stations or grocery store chains, retail implementations, manufacturing floors, etc. Have them image themselves right there as soon as they arrive, have them grab their workloads and deploy, all without a human having to touch them at all. Okay, so Samuel, when you ask about edge sites, we've got some really cool stuff we'll be announcing here in the fairly short order. And yes, it absolutely does work with Storeware, exactly the way that Marcin has been describing.
One thing about this 8 terabytes scale limit, well, we don't require individual drive, one drive for the complete staging space or backup destination. It can virtually be any file system. So the simplest case, and actually it also comes from the other virtualization platforms, where we notice that performance in some cases can be increased by adding more drives, but still you need to have them be visible as a single basket, let's say, single file system. Then you can also use LVM on top of that. So you can have multiple drives attached to the single instance, let's say, of the node, if you would like to scale a bit more than 8 terabytes and join them together with the LVM, for instance, right? So it's a simple.
Absolutely. That you're saying exactly what I was going to answer Wolfgang with is, yes, an individual VSD, we impose a limit of 8 terabytes on. That's a single virtual drive instance. You can have up to 23 of those virtual drive instances in any given workload, in any given VM or container. And logically connecting them is essentially a triviality. I have thousands of customers that do exactly that. Okay.
Okay, so I
So-
believe that we have answered at least the questions that we have had so far. If you have any additional questions, you can always contact us. Drop us any emails, and we are also open for any POCs or trials. So if you would like to test it out, Scale, I believe it's also easily to be tested, but our solution as well is downloadable from our website. So if you can generate your free as well or trial license and check it out, how it works. Do you like it? Give us some feedback. So we are really open for that as well. So thank you
So let
for
me-
watching this. Oh, Alan, yeah.
Yeah, let me do one thing. The scale computing platform is very difficult to describe in detail in a very short webinar. So for the folks that have chosen to take the time out of their day to attend, I will choose to take the time out of my day to answer any questions you might have. So my direct email address is alan@scalecomputing.com. If you have questions, comments, thoughts, concerns, you want to understand anything better, or take a closer look at how this can work in what you have in mind, send me a note. I'll be happy to take some time out of my day and either answer the questions for you or connect you directly to some local folks that can help you get hands-on.
Perfect. Perfect. Thank you, Alan, for today's session as well. So we really encourage you to contact us, give us some feedback, test it out as well, both Scale and Storeware, and stay tuned for the other webinars. Thank you.
Thanks, everybody.